So for this function, let's choose 4 different values. It says 2 integers and 2 fractions, and write new equations. So 1, 2, 3, 4 does not include 2 integers and 2 fractions. As it says, 2 integers and 2 fractions.
So 1, 2, and 1 half, and
let's not do 1 because 1 is kind of there already implied.
Let's do 2, 4, 6, 7, 8, hoodoo.
2 and you want to do 6? Alright, 2 fractions.
6 over 8.
Really? Okay. 6 over 8 is simplified until 3/4. 3/4. Okay, so I have 2, 6, 3/4, one other fraction.
1 half.
1/2. Okay. So using 4 different colors, graph each equation. So I need an axis. There are also colored pencils in your guys' things. Well, there used to be at one point in time.
3 or 4?
3/4 and then 1/2, yeah. So we need an axis.
Okay.
So this is going to be my x-axis. This is my y-axis. What shape does the absolute value take on? It's like a V, right? Okay? It's not curved at the bottom. It comes to a point at the bottom. All right, 10-0. If I am graphing this very first function, what point should I graph?
0.
0 is not a point, so give me an ordered pair. 0, 0.
Origin.
Yes.
We could graph 2, 1.
Not 2, 1.
Wait, 1, 2.
1, 2. When x is 1, y is 2.
2, 4.
2, 4. Okay. 2, 3, 4.
And negative 1, 2.
Negative 1, 2. Okay.
Negative 2, 4.
Negative 2, 4. Okay. So it's shaped like a V, like this. Let me find a straight edge so I can. Guys. Tano.
Stop saying feminine.
Alright, guys. So, what kind of transformation is that to? What transformation? What do we call that? It's not moving up and down. It is y-axis. Yes. Yeah, that's right, Lily. It's a stretch. So I multiplied all of the y values by 2. All right? The x values stayed the same, but the y values multiplied by 2. And when I say I mean Tenno did it. He did awesome.
Thank you.
Good job, Tenno. All right, so let's look at the next thing. What's going to happen for the next one? Okay, so where's the original point? We call it the vertex. Where's the vertex? Alex?
Vertex, that is
Okay, so what's the next point?
It would be 1, 3, 4.
6.
1, 6. You're not paying attention, I know. 1, 2, 3, 4, 5, 6. I have a tendency to call in people who are not paying attention. All right.
What are you talking about?
All right, so what would the next point be? 2 and 12? I don't know.
Well, maybe
2, 3, 4, 5, 6.
Last one.
I moved it up too much.
What's
This is 6.
oh?
I just couldn't count.
Oh.
1, 2, 3, 4, 5. Nope, I was right in the first place. All right, hopefully you guys can count lines better than me.
The last
Okay,
one.
7, 8, 9, 10, 11, 12. So like right here
What?
and here. All right, what do you notice about the shape of the graph?
It gets smaller.
Okay, it gets taller but skinnier, right?
Sure.
What's the slope of each of these? These are lines that are on the side, right?
Yeah, sure.
We have a slope of 6.
Mm-hmm. Yeah. Positive and negative 6. Very good. So we'll have a slope of positive and negative 6, right? A slope of positive and negative 2. For these, this is a positive slope. This is a negative slope. All right, now let's look at 3/4. What does that look like?
What is the 1
1 and 3/4. Yeah. So then the nicest thing to do would actually be what happens when x is 4? What is y? Y is 3. 1, 2, 3, 4. 1, 2, 3. When x is 4, y is 3. What's when x is negative 4? Yep. All right. What happens when x is 0?
Y 0.
Mm-hmm. All right, we could do x is 2, but then when x is 2, what is y?
3 over 2.
Yeah, so 1.5, 3 halves. So it would be when x is 2, y is something like that. 2. Okay. Could you please? What are you supposed to be doing right now? How far ahead of me are you? So your bad behavior is on record now. So what did this 3 halves do to the graph?
It compressed it.
Yeah, it vertically compressed it, horizontally it stretched it by 4 over 3.
So if the x is 2, y would be 6 over 4.
If x is 2, y would be 3 halves.
So 3 over 2.
Yes. So 6 over 4 is 3 over 2, right? Yeah. So yes, you're right. Okay. And so this last one, I'll do it in green. What do we do for this one? Okay. Mm-hmm. So, okay. So when x is 2, y is 1. When x is 2, y is 1. When x is 1, it's 1/2, right? That's kind of ugly. Negative 2 is also 1. What's another value that's kind of nice to graph? 4. When x is 4, what's y?
2.
1, 2, 3, 4. 1, 2. Graphing things wrong here. Okay. 2 and 1. Okay. So what do you notice about the graph now?
It's stretched out x-axis.
Mm. Okay. That 1/2 made it flatter in the y direction and wider in the x direction, right? Which number is bigger, 3/4 or 1/2? 3/4 is bigger than 1/2. Think about a pizza. If you have 3/4 of a pizza, you have all but a quarter of the pizza. 1/2 of a pizza is just half of a pizza. There's more when you're doing 3/4. So 3/4 is bigger. Okay, so that 3/4 is a little bit closer to the normal shape. All right, so let's talk about what have we learned about each variable. What does the h do?
It's two.
Yeah.
Make the I smaller.
It shifts it.
I smaller.
Yeah, it shifts the x value, okay? So it's a left-right. But does it change the shape of the graph?
No.
No, it just moves the graph left and right. Please stop. All right, what does the k do?
The shape of y.
Mhm.
Upward.
So it shifts it up, down. It changes the y value, not the x value, but you add a number to the y value. This one you're adding or subtracting from the x value. What does the a do?
Vertically
Vertically
stretch.
What? I'm sorry. This says shifts left, right, and this says shift up, down. Shift. Yes, this is the F.
Oh, okay.
The shift.
Okay.
You get that. You get a button on laptop.
So what is the point HK called? I just told you a minute ago. It's the vertex. Right? HK tells you the vertex. So your next task is to graph what's shown here. Remember, since we have two things happening vertical, so we have the 1/3 and the 5, which one do I have to do first? The 1/3, yeah. By the way, before we do that, I should say that this A ends up being the slope of the sides.
So how about if we get like a U stuff?
A parabola, that's a little bit different because it doesn't have a constant slope. This one is a line, right? So this one has the slope of 1/2. Rise of 1, run of 2.
So this cannot do the U.
Yeah, so you can't do this for parabolas because parabolas, it goes over 1 up 1, then it goes over 2 up 4, over 3 up 9. So the slope changes for every value of x you choose. Okay? This one is a constant. All right, spend some time graphing this. So that's a really good question. Notice that this says x minus h. So if h is less than 0, I'll have a double negative. So what you'll see is x plus h. So the double negative, when you see x plus h, it actually moves it left. So when h is less than 0, it shifts it left. But you'll see x plus a number. Okay? When it's x, for this instance, x minus 2, what is my h value?
It's -2.
No. X minus h. So what is h?
Oh, positive.
It's a 2. It's a positive 2. Okay? And the k here is...
That means that,
Mhm.
That means that it's shifting to the right.
Yeah, that's correct. It's a right shift.
and then k value means like it'll be on the y-axis about the 5.
Yeah, it would go up 5. Up. Okay, but which do I have to do first? Do I move and then 1/3, or do I 1/3 then move?
1/3.
1/3 then move. Excellent. The a value is 1/3. I hope you guys know. Okay, so I'm going to start with the 1/3 and then I'm going to move it. Okay, so I'm just going to graph. To start with, I'm just going to graph let's call it g of x, which equals 1/3 times the absolute value of x. I'm just going to graph that first, and then I'm going to do the shift second in a different color. So 0, 0. Then remember I said 1/3 is the slope of the sides. All right, so the slope is 1/3. So I'm going to go over 1 and up. Sorry, over 3 and up 1. So it's rise over run, right? Over 1, 2, 3, up 1, 1/3. Does that make sense?
It makes sense.
Okay. 1, 2, 3, 1, 2, 3. Okay, so those are the points for this g of x graph, right? I could fill it in. I'm not going to because that's not my final graph. Okay, but those are the points for just this graph. All right, so now what am I going to do? I'm going to take all of these points and shift them how?
To HK.
HK, okay. The vertex is at 2 and 1, 2, 3, 4, 5. And from here I could do my slope again, right? What is my slope?
1/3.
Okay, so rise 1, run 1, 2, 3. Or I could take this point and move it up 5 and right 2, and I would come to that point, right? Up 1, 1, 2, 3. Okay, so the slope is positive and negative 1/3. It's negative 1/3 on this side and positive 1/3 on this side. 3. All right, so hopefully your graph looks a little bit like mine. Hopefully my graph is right. It looks a little uneven because it's shifted over this way, so it cuts off the side of the graph a little bit more. But does this make sense? This is the final graph of f of x. Right. This was the graph of g here. And that one is the final f graph. Bless you. Are there any questions about that? Instead of doing the more examples, let's go over to the second page. Absolute value functions and equations, how it's all related. So let's talk about that. So the first thing says solve and graph. So how do I solve an absolute value equation? What do I do? What do I do first?
So you just subtract the 4.
No, I want to isolate the absolute value first.
So you
Oh,
subtract
x
over half.
plus 1.
I don't subtract. How is that 1/2
Oh, you
connected?
divide by half.
Divide by half or multiply by.
2.
So the absolute value of x minus 1 equals
Oh, 1/2.
8.
2 times 4. Yeah. 8. All right. So what are the two options? Remember that to drop the absolute value signs, we say, we do what?
Oh, X plus
Okay, we leave it always x minus 1, but this side is, we always leave it, we just drop the bars and change the sign on the the right hand side. So it becomes x minus 1 equals 8 and x minus 1 equals negative 8. Yeah. Okay, so that means either x is, what would that give me? 9 or negative 7, right? Okay. Now, so by the way, the graph means that if this is the x-axis, the two answers are negative 7 and 9. Those are my two answers. So let's try graphing just f of x equals 1/2 x minus 1 on this graph. All right, so let's try. Which direction am I shifting this graph? You guys know how to graph this, right? What do you want to graph first? Yes, I do want that graph first, but where do I start? How do I start graphing that? What, slope? Okay, what's the slope? 1/2. So I could start from 0, 0 and map out my slope, right? Otherwise, could I just start from the vertex and do my slope from the vertex? All right, where's the vertex?
1
Say that again.
4
1, 0. Why 1, 0? There's no K, right? So it's just a shift to the right 1 unit. So this is where my vertex is. So I'm ignoring this part for right now. Okay. So my slope is positive 1/2. So rise over run. All right, so this is that graph right there. Does that make sense to everyone? Yeah?
Why does the graph go back up? If it's 1/2, it's a positive.
So it's a positive slope on this side, but it's a negative slope on this side. Okay?
Is it because it's absolute value?
Yeah. So to the left of the vertex, the slope will always be negative. To the right of the vertex, the slope is positive. All right. Now let's graph f of x equals 4. How do I graph that? It's just a straight line. Which way? Horizontally. Okay, at y equals 4. 1, 2, 3, 4. Horizontal line. So what do you notice about this point right here? This is negative 7.
Oh, you.
This is 8 here, right? So 1 over is where they're going to meet. So it's 9. So this graph meets at negative 7 and 9. These two graphs meet, right?
Is that because the vertex? Wait, why is that?
It's because the only two places that this graph will meet 4 are these two values. But so this, what this is saying is, this is every single value that satisfies this. Okay, this is a straight line. Every single x will only give you an outcome of 4. So where will this give us an outcome of 4 as well? So wherever they meet at 4, those are the two x values that I'm interested in. Does that make sense to everyone? All right, what about this? So what do you notice?
One equation is set to the other one.
Both
The
lines.
solution.
Mm-hmm. So you can find the solutions with one equation set to the other, but what can you notice on the graph?
They cross
Mhm.
where the solutions are.
Exactly.
They intersect.
Yeah.
Interesting.
Do you guys remember how to solve an inequality for absolute value?
Sure.
Yeah. You set the greater than or equal to sign to equal, right?
Mhm.
And then,
It's
So-
and then you
if
put
you
the
divide.
12 will be positive, and the other side will be negative 12.
Okay, and then we switch the sign.
This is probably-
Okay, so first we have to move the 4. That's the first thing that we have to do. Move the 4 over to the right side. So we get the absolute value of x minus 3 is greater than or equal to 8. All right? So that means x minus 3 is greater than or equal to 8. And x minus 3 is excellent. Less than or equal to negative 8. All right, so that means x is bigger than or equal to what value? 11. And x is less than or equal to negative 5. So if I were to graph this out, I'll have a negative 5 and I'll have an 11. Which solutions satisfy?
Between negative 5 and 11.
No. Because look, it says x is greater than 11. So
Oh,
the solutions are going to be above and below. Okay? Those are the solutions. All right, so really quick, we have a couple of minutes left. Let's sketch a graph. It's going to be shifted right 3 and up 4, so I'm going to off-center my absolute values. 1, 2, 3, 4, 5. Put it over here. Here and down here. Oh, sorry. So those are just my x and y axes.
can you start at the vertex?
Pardon me?
You can start at the vertex.
Yeah, so the vertex is where?
Plus 3, 4.
3, 4. Okay, and what's the slope? Just 1. All right, what you'll notice is that, this graph and 12, this graph is bigger than 12 at negative 5 and 11. So 12 will be, I think, right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So this graph is bigger than 12 right out here and out here. Does that make sense when this one crosses? So all x is smaller than negative 5 and bigger than 11. Okay, you guys can go. Homework's on overworlds.
Oh, you said you got homework?
Yeah, of course you do.